During these courses, we will talk about everything about ball mill, tube mill. We will discuss, in the course 1, operation of tube mills, ball mills. On this slide, the tube mill's mimics screen appears. Shows all operating values for tube mill. Material specification: cement mills. Granulometry. Clinker, additives: feed size 95%, less than 25 mm. 100%, less than 50 mm. Uniformity of the feed size ensures stable mill operation. Beware of deviations from kiln and cooler crusher operations. Cement fineness, at workshop outlet. Targets to be defined by quality, production, and process departments. SSB, meter square per kilogram, and rejects, 45 micrometer. The fineness has a great impact on cement strengths and water demand. Moisture. Clinker, additives: maximum inlet humidity, total fresh feed 1 to 2% for open circuit, 3 to 4% for closed circuit, with hot gas. A high moisture content results both in sticking, coating, plugging problems, in the diaphragm slots and elevator, and in poorer cement quality. Temperature. Cement temperature, recommended targets: between 90 degrees and 110 degrees, at mill outlet. Max 70 degrees, in silos. Temperature reflects the level of gypsum dehydration. If temperature degrees is too low, flash set problem. If temperature degrees is too high, false set problem. Influence on strengths and workability. Temperature has to be limited for bag handling, too. Mill grinding. We can ask some questions. 1. Why do we grind? Reduce particle size, he is called mesh. Increase surface area, he is called plane. 2. What does this do? Influences the speed and completeness of chemical reactions. The benefits of the grinding process for both. 1. In raw mix. Particle size influences ease of burning and clinker quality. 2. For coal mills. Particle size has a profound effect on the flame's shape, temperature, and stability, which ultimately influences clinker quality. 3. For cement mills. 325 mesh, particle size, influences 28-day strength. Plane, surface area, influences 3-day strength. Ball mill operating principle. A ball mill is a type of grinder, used to grind using different sized balls. The working principle is simple. Impact. Attrition. Size reduction, take place as the ball drops from near the top of a rotating hollow cylindrical shell. This figure also shows. The ball mill operating principle is simple. 1. Impact. 2. Attrition. Ball mill. We can divide the ball mill into two parts. First compartment: crushing, where there are grinding balls of large sizes. Chamber 1. Second compartment: grinding, where there are grinding balls of small sizes. Chamber 2. Feeding. In this figure shows the components of a ball mill. Feeding clinker. Fresh air flow. First chamber, containing of large sizes balls. Second chamber, containing of small sizes balls. Diaphragm. Main drive. Output cement. Cement is extracted from the mill, in two ways. 1. By suction out the filter. 2. By gravity then transmitted by elevator. This picture from the side also shows the components of a ball mill. Outlet cement. 1. By suction out the filter. 2. By gravity then transmitted by elevator. Feeding clinker and gypsum. Fresh air flow. This video from the site. Type of this mill. Ball mill central drive. This picture from the site shows the components inside of a ball mill. First chamber. Inlet material. Water nozzle. And shows the inside of a ball mill. First chamber. Middle diaphragm. From the side also, components inside of a ball mill. Second chamber. Outlet material. Outlet diaphragm. Water nozzle. From the side also, components inside of a ball mill. Second chamber. Middle diaphragm. There are two methods of operation tube mill. Open circuit grinding. Closed circuit grinding. 1. Open circuit grinding. The simplest grinding circuit consists of a ball mill in closed circuit. Feed. Finish product. The flow sheet is shown the actual layout. Open circuit grinding consist of mill tube, feeder, water spray, discharge system, dust filter, fan, to storage, dust return, main drive. In the open circuit grinding, product sent to storage without returning oversize to mill for further grinding, which makes this process economic. 1. For low blane products, coarser material. 2. The higher the feed rate, the shorter the retention time. Inefficient. 1. For high blane. 2. Closed circuit grinding consists of ball mill feed, separator, material rejected from separator, material fines to silo. Can be defined this process. In the closed circuit grinding is a size reduction process in which the ground material is removed either by screening or by a classifier, and the oversize is returned by integral classification to the mill for further processing. The flow sheet is shown the actual layout closed circuit grinding. It can also be defined as the closed circuit grinding system. All ground materials are led into a separator and classified into refined powder, fine and coarse powder. The coarse powder is returned to the ball mill and ground again with newly fed raw materials. 1. Grinding capacity increases. 2. Grain size distribution of refined powder becomes sharp. 3. Refined powder temperature is reduced. 4. Power consumption rate decreases. 5. the abrasion of liners and balls is suppressed. 6. Grain size distribution of products can be adjusted by changing the circulation ratio and the classifier's run status. In the closed circuit grinding, mill product sent to separator and oversize, rejects, returned to mill for further grinding. Fines taken off as finished product. Converting from open to closed grinding can increase production from 40 to 50%. Overgrinding minimized. Options for adjustment greater on closed circuits. Quality and efficiency better, especially on products over 3,300 Blaine. In this figure is shown the path of the material in a closed circuit cement mill. Ball mill fundamentals. Factors influencing size reduction are: 1. Mill RPM. 2. Mill liners. 3. Air sweep. 4. Mill retention time. 5. Material characteristics, size, grindability. 6. Size, design, and volume loading of the grinding media. Mill types. The grinding mill is the main piece of equipment used in the total raw and finish grinding systems. Grinding mills can be classified into the following categories. 1. Ball mills, tube mills. 2. Roller presses. The ball mill can be divided according to the main drive. Ball mills with 3 drive. 1. Central drive. 2. Girth gear and pinion drive. 3. Integral drive. Normal operation. This figure shows normal operation of ball mill. Operation of tube mills. Normal operation requires: 1. Well-maintained equipment. 2. Steady and normal feed material properties. 3. Minimum interruptions. 4. Well-trained mill operators. Control elements at process ball mill. Control element 4. Weigh feeder. Adjustment of speed. Effect on: 1. Feed rate, mill output. 2. Proportions of components. 3. Circulating load. Control element 4. Separator. Adjustment of rotor speed. Dampers. Rotor blades. Fan damper. Effect on: 1. Product fineness. 2. Granulometry. 3. Specification surface. 4. Circulating load. Control element 4. Static separator. Adjustment of position of vanes. Effect on granulometry of filter dust. Control element 4. Water injection. Adjustment of regulating valve. Effect on mill discharge temperature. Coating. Control element 4. Mill venting fan. Adjustment of position of damper. Effect on mill cooling. Dust granulometry. Abnormal operation. This figure shows abnormal operation of ball mill. Operation of tube mills. One of the most important notes on abnormal operation. 1. Changing in feed material properties. 2. Equipment problems. 3. Deficiencies of control elements. 4. Sensing elements deficiencies. 5. External effects. Checklist, abnormal operation, for tube mills. Indication. If the cement too coarse. Possible reason. Mill overfilled. Separator adjustment. Mill feed very coarse. Filter dust too coarse. Action. Low mill feed rate. Proper adjustment. Improve pre-crushing. Adjust static separator, or venting rate. Indication. If the cement too fine. Possible reason. Mill underloaded. Separator adjustment. Mill feed very fine. Filter dust very fine. Action. Increase mill feed rate. Proper adjustment. Further investigation required. Adjust static separator, or venting rate. Indication. Wrong chemical composition. Possible reason. Wrong feed proportions. Wrong feed components. Action. Adjust proper proportions. Change component quality. Checklist, abnormal operation, for tube mills. Firstly. Mill. Indication 1. Sound dull. Possible reason. Mill overfilled. Action. Lower feed rate. Indication 2. Sound loud. Possible reason. Mill underloaded. Action. Increase mill feed rate. Secondly. Cement temperature. Indication. Too high. Possible reason. Clinker temperature too high. Low mill or separator venting. Lack of water injection. Cement cooler failure. Action. Check clinker cooling. Adjust venting rate. Adjust flow rate. Mechanical replacement or repair. Checklist, abnormal operation, for tube mills. Firstly. Mill output. Indication. Too low. Possible reason. Unsuitable ball charge composition, or badly worn balls diaphragm unsuitable, or clogged. Unsuitable or worn liners. Change of feed grindability. Coating of balls. Adjustment of separator. Operator's error. Action. Change ball charge. Replace or clean diaphragm. Replace liners. Further investigations required. Improve cooling or use grinding aids. Adjustment. Instruction or training. Secondly. Mill exhaust pressure. Indication. 1. Too high. Possible reason. Inlet or outlet clogged. Diaphragm clogged. Action. Clean inlet and outlet. Clean diaphragm. Indication. 2. Too low. Possible reason. Diaphragm broken. Major false air penetration. Action. Replace broken plate. Seal sources. Comparison between closed circuit and open circuit. Finer grinding in open circuit leads to coating, leading to inefficient grinding. In closed circuit, the mill product is passed to a separator and divided into product, fine and coarse, the coarse which is circulated back to mill. Circulation factor, C, expresses the average number of passages of material through the mill before it leaves the grinding system. Circulation number should be increased with increasing product fineness. Separator control. Separator control options. 1. Rotor speed. 2. Air volume. A. Constant air flow through separator. Lower rotor speed equals coarser product. Higher rotor speed equals finer product. B. Constant rotor speed. Lower air flow through separator equals finer product. Higher air flow through separator equals coarser product. C. Constant product fineness. Lower air flow through separator equals lower speed. Higher air flow through separator equals higher speed. Cement mill control loops. 1. Composition of the feed to the mill. The feed consists of 2/3 raw materials, clinker, gypsum, additive. The weigh signals from the respective feeders are used to maintain the set proportion of the feed components. 2. Constant feed to mill. The total feed to the mill equals fresh feed plus separator returns. Total feed set by the operator is kept constant by adjustment to the fresh feed. Folaphone, electronic ear for ball mill, signal as supervisory control. 3. Airflow through separator. Airflow through the separator is kept constant by maintaining constant power consumption of separator fan by adjustment to its speed. 4. Mill outlet temperature. When mill is in operation, the mill outlet material temperature is kept constant by injection of water at the mill outlet. 5. Product temperature. The product temperature, after the bag filter, is controlled by opening of the separator cold air damper positioned in the air duct between the separator and fan. 6. Under pressure at mill inlet. The mill inlet pressure is kept constant by adjusting the filter fan inlet damper. 7. Separator inlet under pressure. The under pressure at the separator inlet is kept constant by adjustment of the damper in the recycle duct, positioned between the separator fan and separator. Cement mill internals, water spray. To control the dehydration of the gypsum, the cement temperature at the mill outlet as well as inside the mill should be maintained below 115 to 120 degree. Mill is provided with outlet water spray system. When water is not sprayed, compressed air is purged through the water nozzle to avoid its blockage. Finish mill water sprays. This figure shows poor atomization, spray lands on load. This figure shows excess atomization, spray goes into airstream. Poor atomization leads to loss on ignition increases. Exit air temperature high. Excess atomization leads to discharge material temp high. Spray controlled by nozzle. Design and air or water ratio. Spray locations. This figure shows the locations of water spray in tube mill. 1. Feed end. Mechanically simple, process problems. 2. Partition. Mechanically problematic, best for process. 3. Discharge end. Good if mill is weakly vented, and or short compartment or only small amounts are needed. Gypsum phases. The chemical formula of gypsum, CaSO4, 2H2O. Calcium sulfate hemihydrate, CaSO4, 1/2H2O. Known as plaster of Paris. Anhydrous calcium sulfate, CaSO4. The benefit of adding gypsum. Hemihydrate goes into solution and forms, Ettringite coating around, C3A, prevents early set. Hemihydrate formed by dehydrating gypsum. Also depends on C3A reactivity. Why gypsum is added to cement? Gypsum is added to cement to 1. Prolong hydration. 2. Increase strength after hydration. 3. Decrease the heat of hydration. 4. Reduce curing time. Note: if gypsum is not added to the cement, then it can result in immediate condensation of cement clinker on the addition of water. This is caused by the fast dissolution of tricalcium aluminate in water, which produces calcium aluminate hydrate, a clotting agent. In the presence of gypsum, the tricalcium aluminate reacts with the gypsum on hydration to produce calcium sulforaluminate hydrate, which forms a protective layer on the cement particles that hinders with the hydration of more tricalcium aluminate, leading to a delay in the time of the setting of the cement. Flash set. False set. Flash set, known as insufficient coating, C3A reacts, resulting in a permanent set. False set, known as too much plaster, resulting in a weak plaster set that can be broken by remixing. What is the difference between false set and flash set? Flash setting. This is due to a lack, or absence, of calcium sulfate, gypsum anhydride, addition to clinker. This addition is useful to divert the natural hydration route of aluminate phases, from hydrogarnets and other hydroaluminates towards ettringite. Hydroaluminates induce flash setting, a rapid and exothermic hardening in a matter of minutes. Ettringite and counterparts induce a much softer hydration route, easier to manage in terms of workability. False setting. This is usually due to thionaturia of calcium sulfates added, specifically too much calcium sulfate hemihydrate, basanite, or more commonly plaster. Calcium sulfates come in various degrees of hydration: dihydrate, gypsum, hemihydrate, basanite, anhydrous, anhydride. When too high an amount of hemihydrate is present, it simply follows its own hydration route towards gypsum precipitation, leading to an early setting of cement. Hemihydrate may form in hot spots of the mill during clinker gypsum co-grinding. 120 to 148 degrees C is enough. Ball coating. Ball coating softens, impact, therefore grinding efficiency is lost. Can reduce lifting effect of liners. Separators will reject agglomerated particles as a coarse piece. Here is a video that shows the effect of grinding aids on grinding balls after coating. Performance tests should be carried out on the following occasions: after startup of a new mill, to verify the guarantee figures; low mill output or poor product quality; high operation or maintenance costs; Implementation of new processes and techniques. Planned capacity increase. Complete mill performance test. Comprises basically, the following work. Determination of mill output, and power consumption. Sampling within grinding system. Sampling inside mill. Gas flow measurements. Recording of operational data. Visual inspection of equipment. Evaluation of test. Startup of a new mill. This table shows the values and steps that must be followed when running new mill. Conclusion. Why do we grind? Reduce particle size, increase surface area. Influences speed and completeness of chemical reactions. Types of mill circuits. Open, closed, and pre-grinding. Types of mills. Ball mill, roller mill, and roller press. Grinding dynamics. Crushing and grinding. Cataracting and cascading. Air separation. Particle size classification. Coarse material returned to mill, fine material drawn off as finished product. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.